Hello, I am audible. Sagar, please confirm just. You. Okay. Thank you. Let us wait for 5 minutes for another participant maybe join. Then after we'll start. Hello, I am audible. Our slide is visible. Please, you can write in the chat box. Question number 1. Sagar, please just confirm me whether question number 1 is visible or not. Okay, let us start. I am Om Prakash Maurya from IIT Guwahati. So today we'll see the assignment number 7, previous year fluid mechanics, NPTEL. So the first question is, which one is not a primary dimension? Velocity, time, length, temperature and mass. So please, based on your knowledge or whatever you have learned in the NPTEL, this year NPTEL 2024, you please write your answer in the chat box. Which option will be correct? Here only one option is correct. So please try to write your answer in the chat box. Take time, think on that. So I'm waiting for your answer in chat box. Then after I will explain what is the primary dimension and other related things with primary dimensions and all. So week 7 is related to the dimensional analysis. Okay, good. So Sagar is telling the option A will be correct. Yes, definitely option A will be correct, because here asking the primary dimension, not a primary dimension. So velocity, definitely the unit of velocity, if you want to know, so velocity is nothing but meter per second, that is distance by time. These things we will use in the later part, later questions, please remember. So definitely time, length, temperature and the mass is the primary dimension, are the primary dimension. So here you can see, or you can also call this is the fundamental dimensions, fundamental or the basic dimension. How many? 7. Mass, length, time, temperature, electric current, amount of light and the amount of matter. So remember please, your primary dimension is only 7. Velocity, your is the derived dimension, that is the meter per second is the derived. So later we use these things, velocity, when we study the similitude. Now moving ahead on the next question, which similarity condition is related to force scale equivalence? Question number 2. So which similarity condition is related to force scale equivalence? Geometric, kinematic, dynamic, and the kinematic and the dynamic, both. So please think on that and try to give your answer. Here we are talking about, actually question is asking about the force scale equivalence. So basically for dimensional analysis, when you make a model for a particular prototype, so you need to maintain the geometric, kinematic, dynamic similarities. So question is asking about similarity condition is related to force scale. We need to make the similarity between length parameter, kinematic parameter, dynamic parameter. So please you can write your answer, then I will discuss all these 3 similarities in detail. So you can write your answer in the chat box. Okay, now let me discuss. So here in geometric, basically in geometric similarity, let me write geometric similarity. We discuss about length parameter. Like width, length, thickness, or you can say the depth, whatever. This type of parameters we look in the geometric similarity. Now, what is kinematic? Kinematic similarity. In kinematic similarity, basically we see the velocity part. In dynamic, etc. also, here is not a space. In dynamic similarity, we look the forces, like how many forces acting on, like suppose you want to make a ship, that is a, this is a prototype. If you will see, this is the prototype, that is bigger one. When you will model this is the prototype. When you will model very small as per your laboratory condition. So this is model. So you will maintain the length, width and everything, how much water is flowing. So here water and water everywhere. So what is the water velocity this side? What is the velocity of this, your boat? If this is river, then velocity definitely. How much force, that is drag force, friction force acting, similar thing you will maintain in the model. Then you will get the actual condition or actual parameters, whatever you want to find out, velocity, turbulence, everything. So as for this question concerned, question number 2, the force scale equivalence we look in the dynamic similarity. Remember please. So now moving ahead with the new questions. Next question. So yes, so here dynamic similarity condition is related to your force scale equivalence. Remember please, dynamic similarity is related to force equivalence. Force scale equivalence. Now moving ahead with question number 3. So this is very important. Okay. So question number 3 is, consider unsteady fully developed fluid flow between two infinite parallel plate. Two infinite parallel plate. This problem involves the following parameters: velocity component, distance between plate, vertical distance y, top plate speed v, fluid density rho, fluid viscosity mu, and time t. The number of expected non-dimensional parameter pi's, that is pi's for this problem. So whether it will be 6, 4, 5, 3. So this is very important question for your Buckingham pi theorem, or you can say the topic of dimensional analysis in fluid mechanics. So please, just based on your knowledge, you try to give your answer in chat box within 2-3 minutes. Then after I will explain if you will not able to give your answer. So I am waiting for your answer. You just try to solve whatever you have studied. So here in this question we are talking about pi's, number of pi's for solving such type of, or basically identify the relation between these variable. Here if you will count how many variables: velocity component 1, distance between the plates h, that is 2, vertical distance y 3, top plate speed 4, fluid density 5, fluid viscosity 6, and time is 7. So here you have the 7 variable. It may be dependent or it may be independent. So a little bit hint I have given you. Now you can try. Okay, now I want to discuss. So here basically you have the 7 variables. Number of variables is number of variables. How much? That is your small velocity, distance between plate, y, top velocity, capital V, fluid density, fluid viscosity, time. So here you have the 7, 1, 2, 3, 4, 5, 6, 7. So how you will calculate that is pi, number of pi's. So here you need to select three fundamental, that is the whatever I was discussing the fundamental dimensions or the primary dimension you can say. So here you need to consider. So here if I show you, number of parameters is how much? 7, whatever I have discussed. N is equal to 7 given. So number of primary dimension, how much you want to, actually we need 3 primary dimensions, always remember please. So it will be your 3. So this is the your required primary dimension. When you will look the procedure for how you will solve this particular problem, such type of problem through the pi theorem, Buckingham pi theorem, then you will easily get what is the use of primary dimension, what is the use of pi's, that is the Buckingham pi's, number of pi's. So please, if you not know what is the pi's and what is the primary dimension, why we are selecting 3 only and all, so please go through lecture, video lecture, or you can follow the some standard book, or you can see my previous NPTEL 2023. I have discussed in detail through PPT. So I have discussed basically from Sinjal Simbala book, Fluid Mechanics. So you can follow my previous week 7 NPTEL 2023 of Fluid Mechanics. So primary dimension here you need to select 3. So your pi theorem is nothing but, therefore the pi theorem, number of pi's will be equal to number of parameters minus primary dimension. It will be equal to 4. So this is an important question. Remember please, such type of question you can expect in your coming exam or final exam. Next question, question number 4. Question number 4 is the primary dimension of kinematic viscosity is, the primary dimension of kinematic viscosity, m dot L by T square, m divided by LT, L square by T, L square divided by m dot T. So which option is correct for question number 4? So please, I want answer from your side. I will discuss in detail how you will calculate for new student. For new student, I will discuss how you will get the dimensions and all. So please try to give your answers in the chat box. You have the 2-3 minutes. If you not know the dimension of viscosity, kinematic viscosity directly, you can derive from your basic fundamental equation of Newton's law of viscosity and your definition of kinematic viscosity. Use these two things, then you can derive and write the equation. You have 2-3 minutes. Within 2-3 minutes, you can easily derive the unit of kinematic viscosity. Oh, Sagar has left. I think some network issue with Sagar. So the answer of this question, let me derive for some student. Those are new student, very difficult to how we will calculate. So basically from the Newton's law of viscosity, you know already your tau is equal to nothing but dynamic viscosity into velocity gradient du by dy. So basically when water is flowing, so your velocity gradient like if here is u, here is u plus delta u and this is delta y. So how much increase this u? So increase, how much increase? Increasing delta u when you will go up by delta y. So this is velocity gradient. So now you need to put here your dimension. Shear stress is equal to force by area from the basic, very basic fundamental. Then your dynamic viscosity. And what is kinematic viscosity? If I tell you, which is represented by nu, that is mu divided by, that is dynamic viscosity divided by rho. Someone join, I think. Oh. Okay. So Sagar, I am discussing the answer of this question. So basically, here just I have discussed the shear stress is equal to your dynamic viscosity into del u by del y. That is velocity gradient. How you will get the velocity gradient I have discussed. So your shear stress is equal to force by area from the very basics and your du by dy. Your kinematic viscosity you know already. So first you need to find out the dimension of this. Then after dimension of rho. So rho is nothing but mass by volume. So you will get the dimension that is kg by meter cube. But here force is nothing but mass into acceleration divided by A into mu u by y. Because here I am going to find out the dimension, so there is no meaning of the du and dy when we will find out the dimension. So mass is kg, meter per second square for your acceleration, and area is meter square, mu meter per second, and this is meter. So this meter will be cancel out. 1 second and this second will be cancel out. Here 1 meter and meter will be cancel out. So your mu is equal to nothing but kg divided by meter second. So this is remaining. Mu is equal to kg meter per second. So here you need to put kg meter into second divided by rho. So the dimension of rho is nothing but kg per meter cube. So this meter will be cancel out. Here only meter square and this kg will be cancel out. You will left with only meter square by second. So meter square by second means nothing but your L square, that is the, when you will go the primary dimension, that is length, L square, and second is T. So L square by T will be the primary dimension of kinematic viscosity. Remember please. How you will quantify, how you will add, calculate, I have discussed. So you please go with videos. Now moving ahead with the next question. Option C will be correct for this question. Question number 4. So the next question, a model of reservoir. Question number 5. A model of reservoir is inputted in 10 minutes. If the model scale is 1:25, the time taken by the prototype to empty itself would be. So you have first to try to, then I will explain. So now I voice is not coming. Why is voice is not? You please. Oh, Sagar left out. Sagar, now I'm audible because from my side it is okay. There is no issue. You just check your side. If network will be not good, then it is very difficult to see my video and as well as my voice. Listen my voice. So please just confirm whether I'm audible or not in the chat box. Oh, let me just write in the chat box. Oh, so why I'm not audible? Okay. Now audible? Let me just check. Hello? Hello? Okay, why I'm not audible? Whether some setting issue or what? Hello? 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 Really, I'm not audible. Let me just check the setting. Setting is okay, I think. I think recording is also, yeah, recording is good, no problem. Okay. So, is there any? Hello? Okay, I'm audible, but I'm using the mobile phone. Okay, let me put it. Okay, now I'm audible. Okay. Okay, please listen. I'll use mobile for you, but I don't know why I'm facing the problem today. Okay, I will resolve later. Let us go with the questions. So the question number 5 is a model of reservoir is emptied in 10 minutes. So whether you got question number 4 or not. Okay. So the next question is a model of reservoir, question number 5, is emptied in 10 minutes. If the model scale is 1 is to 25, the time taken by the prototype to empty itself would be. So just please try to solve this question, question number 5. Okay, you are telling the option, okay, you have already solved. So let me just discuss how you will get the correct answer. So here we are talking about the time taken by empty the prototype. So basically, let us just for feel, the your prototype is nothing but that is the bigger one. The reservoir will be bigger one. So this is the reservoir. Just suppose the bigger one. The water is this side is okay. For prototype, this is the prototype. For model, it will be very, very small. So this side water. So this is the model. So in model, for empty the reservoir, take time is equal to 10 minutes. If the scale is 1 is to 25, it means what? Here is dimension is 1. Here in prototype, if length suppose 25. So we have taken in model length is equal to 1. 25 if it is centimeter, then here 1 centimeter. If 25 meter, then here 1 meter. So what is given? LP by, that is the what is given, 1 is to 25 is given. So LM by LP is given 1 by or 1 is to 25. Remember please. Now, so here we need to find out the relation between time of prototype and the time of model. So basically in gravitational type of flow, we consider Froude number. So how we'll consider the Froude number? Fr for model is equal to Fr for prototype. So model means what? V model divided by root ZD, capital D. Capital D is nothing but, if you know already from the fluid, from the open channel hydraulics, is by area by top width. Area by top width equal to, here is also your model, and the velocity of prototype divided by Z D prototype. So if I calculate why, let me first find out the ratio. Vm by Vp is nothing but root Gz will be cancelled out because it is constant. Root and D is what? Area by top width. So when you will calculate the here dimension, you will get the dimension of length, that is Lm by Lp. So you got this. So Lm by Lp you can write Lr, that is the ratio. So sometimes, or Vm by Vp we can write Vr. So Vr is equal to nothing but root Lr. So this is the fundamental. Now your velocity is related to distance by time. So if I compare velocity of model equal to velocity of prototype. So d, that is a small d of model, and t model is equal to a small d of prototype, t of prototype. So from here, what you will do, that is your dm by dp. If you want to write, so you can write here L, because d is related to length. So Lm divided by Lp is equal to nothing but your Tm by Tp. So you can write these things. So now you can equate. Now these things you can write the Tr. So now you can very easily write here Tr is equal to nothing but root Lr. So now the value is given, Tm is equal to, so here I think, let me write this thing again. Vm by Vp is equal to root Lm by Lp. So if I write here one thing, V is equal to nothing but your distance by time, that is m, divided by distance by time for P, that is Lm by Lp. So your Tp will be like that, Tm LMLP. So when you will calculate the prototype, you will got it, that is the Tm, this is 10 into 1 by 25. Okay. So here I think it is minute or hour. How this calculation is done, I don't, actually here I think some mistake is, because velocity is nothing but your distance by time. So when we will compare this meter per second, definitely your T will be go, that is a prototype will be go up. So if you will calculate like that, your value will come 0.4 minute. In second, if you want to, I don't know, if I think some mistake is there in this question. These things you cannot write. Okay, we'll discuss this question in the next class. I think some mistake is here, because velocity is related to distance by time. When you will calculate, the answer will come like that. Okay, don't worry, we'll see this question in the next class. Now we'll move ahead with the question number 6. The ratio of internal force and the surface tension force is generally known as. Just please try to give your answer in the chat box. Okay, the answer of this question is nothing. The ratio of force, inertial force and the surface tension force is Weber number. So here you can see the inertial force is the root under inertial force divided by surface tension force is equal to V by root under sigma by rho. So now we move ahead with the next question. Next question is the dimension of pressure gradient in a fluid flow is given by. Dimension of pressure gradient in the fluid flow is given by. So please try to solve this question. Question number 7. The dimension of pressure gradient. So you can write your answer in the chat box. Okay, please. In the previous question, whatever we have discussed, so from up to that, let me just erase. So basically, we need to find out whatever the relation we are finding. We'll use only the your concept of root number, not the another formulas for velocity. That is your traditional formula. You will not use here. So how you will get? Let me discuss. So your velocity is nothing but distance by time. So this is your VR is equal to Lm by Lp. So you can write here Lr. Now you know already your velocity time is equal to nothing but time is equal to that is your velocity is equal to what? Velocity is equal to your length divided by time. So time is equal to length divided by v. So here you can write T is equal to Lr divided by Vr. So Lr okay. And Vr is nothing but root Lr. So from here you can go get the T is your root Lr. So now you can write Tr is equal to root Lr. So nothing but Tm by Tp is equal to root under Lm by Lp. So 1 is to 25. Okay, previously we used 10 divided by not. Okay, so 25. So here T you need to calculate what? Tp. So Tp is nothing but Tm is given 10, 1 is 5, and Tp is equal to 50. So your prototype will be completed with within 50 minutes. So hope you will got it what I was discussed previously what I was doing mistake. So now it is corrected. So how you will proceed with this such type of questions? So your T is equal to LR by VR. So you will previously I was doing uh, same thing but in the different way. So but you should follow the ratio of LR by VR for calculating the T. So now moving ahead, the question number what we are discussing, the dimensions of pressure gradient. So here pressure gradient, anyone give the answer in the chat box or no? Okay. So let me discuss the pressure gradient. So the pressure gradient is nothing but like your velocity gradient, what you write du by dy. Similarly, here you will write pressure, change in pressure with respect to change in depth. So that is your pressure gradient. Right. So pressure is equal to what? Force by area. And this is Y is given already. Force nothing but ML T minus 2. How you will get force is equal to nothing but mass into acceleration. So mass is kg acceleration meter per second square. When you will convert in the dimensional, so mass that is m kg m l t square. So you can write m l t minus 2. So directly I have written here force is equal to mlt minus 2 area is equal to L square and Y L cube. L. So here L cancel out. So M L minus 2 T minus 2 will be written. So your pressure gradient, the dimension of pressure gradient is nothing but M L minus 2 T minus 2. M L minus 2 T minus 2, option D will be correct for question number 7. Now moving ahead with the next question. Next question is, a ship with full length of 100 meter is to run with a speed of 10 meter per second. For dynamic similarity, the velocity for 1 is to 25 model of the ship in the towing tank should be. So please try to calculate. 4 option is given: 2, 10, 20 and the 25 meter per second. So please try to calculate the answer of this question. You can write your answer in the chat box. So the answer of this question is nothing. If you will look the previous question concept, same concept here you will use. The concept is the dynamic similarity. So here you need to find out the velocity. You know already. The here you will also use your fluid number similarities FR. Model is equal to FR prototype. So FR model is nothing but V model divided by your root Z whatever D will be. Z is nothing but area by top width. V prototype. So here V model divided by V prototype will be nothing but GG will be cancelled out. So D is what? D is a length parameter. How? D is equal to area by top width. So area by top width is nothing but that is meter square divided by meter. Top width here we are talking about, not time, top width. So only length will remain here. So you can write LM by LP root under. So your Vm divided by Vp is equal to, if this thing we'll write Lr, so you can write Lr, or Vm by Vp you can write the Vr also, the ratio of model by prototype. So it is given you 10 meter per second. V prototype is given and ratio is given 1:25. So Vm is equal to 10 into 1 by, this is 1 by 5. So it is 2 meter per second. So your prototype velocity is 10, but your model velocity will be 2 meter per second. So this, so similarly, as similar to the previous question. So now moving ahead with the next question. Next question is the which one of the following is not a fundamental dimension? So please try to give your answer in the chat box. You can write your answer in the chat box, please. So basically here is asking about lot of fundamental dimension. So length is a fundamental dimension, mass is fundamental dimension, time is fundamental dimension, but pressure is, that is the pressure is nothing but that is force by area. So you can write the dimension of the pressure here, Newton per meter square. So it is derived, not a fundamental. Using the fundamental dimensions, we have derived this Newton per meter square. So your option D will be correct here. This is not a fundamental dimension. Next question is geometric similarity between model and prototype. Geometric similarity between model and prototype means similarity of linear dimension, similarity of discharge similarity, similarity of motion, similarity of force. So which option is correct for this? Which option? So basically your geometric similarity is the relation between your model and prototype is similar in linear dimension. Similarity in linear dimension. Remember please. Next question, question number 11. For a fruit model law, find the ratio of velocity and discharge in terms of length scale. Velocity as well as discharge you need to find out. here is the answer of this question is nothing but we'll find out by using the Froude number. So the Froude number similarity here same thing. So VR1 is equal to VR model divided by FR prototype. So similar thing. VM divided by your, here I will write direct LM is equal to V prototype divided by L prototype. So Vm by Vp is equal to nothing but your root Lm by Lp. These things. Now, so the first answer of velocity, that is your Vr is equal to root Lr. So in every option Lr is given. So now moving ahead with the discharge. So discharge is area into velocity. So that is Ar divided by Vr. So AR is LR square into LR half. So when you will calculate, you will get LR is equal to 5 by 2. So your discharge is related to LR 5 by 2, or you can write LR 2.5. So option D will be correct for this. Now the next question is, a geometrically similar spillway model is constructed to a scale of 1 is to 16, corresponding to a discharge of 1024 cubic in prototype. The discharge in the model will be. So, so please write your answer in the chat box for question number 12. Yes, Krishna, you want to say something? You are not audible, please. You can write in the chat box. So please try to write your answer in the chat box. Okay, let me solve. Let me solve the answer of this question, question number 12. So here is your geometric similarity is given, that is Lm by Lr is given 1 by 60, and the prototype discharge is given you 1024 cubic. The discharge in the model in cubic will be discharge of model you need to find. So here you will use what? Again, Froude number similarities. Vm by Lm equal to Vp divided by Lp. So here Vm by Vp is equal to Lm by Lp. So that is Vr is equal to ratio root under Lr. So discharge is equal to what? Velocity into area. So velocity, that is Qr, that is Vr Ar. Vr is equal to nothing but Lr, and Ar is equal to your Lr square, because meter square. L is area is meter square. So here L to the power 2.5. Lr to the power 2.5. So Qm by Qp is equal to Lm by Lp divided by 2 power 2.5. So here Qm you need to calculate. So Qp is given already 1024 into Lm by Lp is given 1 by 16 power 2.5. So now you need to calculate how you will get. Let me calculate using the calculator. So 1 is to 16. 1 divided by 16 1 divided by 16 to the power 2.5 into 1024. 1024. It will be 1. When we will calculate, it will come exactly 1. 1 meter cube per second, or you can write here cubic. Cubic. Now we'll move in the next question. Next question is, next question, in a 1 by 50 model of spillway, the discharge of prototype is 5303 meter cube per second. The corresponding model discharge in meter cube per second is 2, 1, 0.5, 0.3. So please try to calculate. So here again the answer of this question is your discharge is given or prototype discharge is given and LR is given already 1/50. So model discharge we need to calculate. Q model. So again Q model is equal to nothing but QP and LR to the power 2.5. So it is given 5303. Similarly, as of whatever I have done above, similar thing you will do here. That is LR is nothing but 5303 to the power 2.5. When you will calculate this, let me calculate. So here is LR is, let me write again, 5303 into 1/50 to the power 2.5. So 1 divided by 50 to the power 2.5 into 5303. It will become 0.299. So almost you can say 0.3 meter cube per second. So it is very easy. Now the next question is very interesting. List 1 contain the dimensionless parameters and list 2 contain the ratios. Mach number, Reynolds number, Weber number and the Froude number. So the list 2, the ratio is ratio of inertial force to the gravitational force, ratio of fluid velocity and the velocity of sound, ratio of inertial force to the viscous elastic force, ratio of inertial force and the surface tension force. So 4 option is given, 1 A, B, C, D. So sometimes as a civil engineer we generally we use these two things, Reynolds number and the Froude number. We always know the formula of this and formula of this. So think on that how you will find out. So basically for Reynolds number you know already, Re is equal to your inertia force divided by square root of, remember please, not only the here the ratio of square root of in each, here and here, I by your viscous elastic force. Viscous elastic force I want to write like this. Froude number you know already, root under inertia force divided by your gravitational force. Gravitational force. So these two things, let me just match. Reynolds number, ratio of inertial force into viscous elastic force, that is option, that is Q is matched with the 3. So Q matched with the 3, option maybe C or maybe D will be correct. Come with the Froude number. Fruit number is ratio of your inertial force divided by gravitational force square root of. Remember please, the ratio of square root of inertial force to the gravitational force. So S goes to 1. So your option C will be correct. So what is P is related to 2. So the Mach number is the ratio of fluid velocity and the sound. Remember please, the Mach things, that is the Mach number we use always in the, whenever we use the when we compare the things with the your sound velocity, that is the rocket launch. And the mechanical, generally the mechanical people and the aerodynamic people use these things, but as a civil engineer I think very less use of this Mach number. Now the Weber number is the ratio of, that is option 4 for R, inertial force divided by surface tension force, whatever we have seen above. That is the in this question. Where is the question? Here you can see the derivation. The Weber number is the ratio of inertial force divided by surface tension force. Inertial force is nothing but the force due to your mass as well as velocity. Remember please, mass velocity, how much mass is moving with a velocity, with the how much velocity of fluid flowing, and the what is the mass. Remember always represent the inertial force. So the next question number I think this was the 13, 14. The last question is last question for today. A device operating on a surface of a liquid to study using a model with the ratio of 1:20. Again, the ratio is given here 1:20. What should be the ratio of kinematic viscosity? Kinematic viscosity between model and prototype, so that the fruit and the Reynolds number remain the same. Your fruit number and Reynolds number remain the same. So here two condition is given. So whatever we derive the formula for your model, and that is a kinematic viscosity relation with the your LR, that is the ratio of model and prototype. We use these two things, fruit as well as your Reynolds number. So you can think little bit how you will proceed, then I will show you the answer. Or I think in video no one, so I can directly write the, okay, no one is, so I can directly discuss the answer. So here actually given 1:20, I think yes. LR is given 1:20. So Reynolds number is what? Velocity divided by rho v d, I can write L, rho v L by mu. So I can write VL divided by kinematic viscosity. Let me write with the Vk, or nu, I can write nu k. Fruit number is nothing but velocity divided by root z I can write L here because area by top width, so L will be remain. So for model, so here you can write the two equations, that is Vm Lm divided by Vkm, that is kinematic viscosity M, is equal to V prototype L prototype divided by mu K prototype. So this is equation 1. For fruit number, Vm divided by G will be cancelled out, so Lm, and V prototype divided by L prototype. So these two equation. Now you can divide this side and this side. So when I will divide this, so Vm Lm divided by mu Km divided by how much? Vm divided by root Lm. This side also divide similarly. Vp Lp Vkp, that is new Kp, sorry, Vp root Lp. So equation 1 divided by equation 2. So L, V and V cancel out, and this Lm will be go this side. So Lm to the power 3 by 2 divided by nu Km. Similarly here Vp Vv cancel out, and your Lp to the power 3 by 2 and V, that is nu Kp. Okay, so now you can compare these two things, that is nu Km divided by nu Kp is equal to Lm divided by Lp to the power 3 by 2, or you can write 3 by 2 as Lm by Lp, you can write 1.5 also. So here what actually, in question, so Lm by Lp you can write, that is your Vkm divided by Vkp, new Kp, not V, that is Lr to the power 1.5. So Lr is given 1 by 20, and this thing you can write nu Kr, that is the ratio, to the power 1.5. So your option C will be correct according to this method. So yes, your option C will be correct. So remember please always how you will proceed such type of question. Actually such type of question you can expect in your coming examination, whatever the exam is coming for GATE exam, as well as your NPTEL fluid mechanics final exam. So such type of question you can expect. So if anyone having any queries, please you can comment in the video, as well as you can write me mail also. Let me write here my mail. And another mail is, oh, so anyone can send me the screenshot of whatever you are facing the problem in your any questions, or you can write mail me also. Okay, so these are the discussions. So I think the next your next week will be, I think this week will the dimensional analysis. So they will meet with the new questions in the next class. That is the week number 8. So this is week 7. So okay, thank you.